Hello friends, our today's session we are going to study one very important concept of calculus, and that concept is called as derivatives. Now before I go to the definition, the physical or the mathematical definition of derivative, let's try and ask some questions to ourselves. For instance, if I take a rod and I start hitting it, let's take a rod and we start hitting it, and the temperature is going to raise, isn't it? After some time the temperature is going to raise. Now as the temperature keeps on increasing, have you noticed that the rod will also start expanding? Is it the length of the rod also keeps on increasing? That means you can say from here, as the temperature changes, as the temperature increases, or I should say better, the length of the rod will also keep on changing. It will also keep on increasing, because we know from physics that if we start hitting a particular object, the object will start expanding. That means the physical quantity length of the rod depends on the physical quantity temperature of the body. As the temperature increases, there is an increase in the length of the rod also. That means one quantity depends on another quantity. So this dependency, if I want to find the rate, that dependency will be called as derivative. For instance, let's take one more example. If you start running, you will definitely cover some distance in a given particular amount of time. So the distance that has been covered in a particular amount of time, as the time increases, the distance covered will also keep on increasing. So this is nothing but what? One quantity, one physical quantity, the distance is changing with respect to what? With respect to the other physical quantity, which is time here. That means here also there is some dependency, isn't it? So this dependency is called as derivative. So derivative, if we want to define, it is simply nothing but rate of change of a particular quantity with respect to some other quantity. For instance, as I said, velocity. If I want to understand velocity, it is nothing but what? It is the rate at which the displacement is changing with respect to time. Similarly, if you want to understand what is acceleration, so acceleration is nothing but what? It is the rate of change of velocity with respect to time. One physical quantity is changing with respect to some other physical quantity. So this rate of change, this rate measure is called as derivatives. So in layman's term, if you want to define what a derivative is, it is basically rate measure, or you can say rate of change of a quantity with respect to some other quantity. So students, this is what the basic definition of derivative, what you need to know about. Now in our today's session, we are going to understand derivatives in far more detail. So I welcome you all to this channel Pankaj Lade, where you will be learning today about derivatives. So let's begin, students. Derivatives. Now what do you have? This is a very big chapter and a very important chapter with respect to the calculus part of mathematics. So it becomes very important that you study this chapter very thoroughly. What does this chapter contain? What things are there? We are going to see in a short while from now. So basically, if I want to start with the topic derivatives, remember that derivatives, we will be breaking into small parts. We will be taking small lectures of every single part of derivatives. So stay tuned for all of my lectures. So derivatives, the first thing that you'll be learning in derivatives is called as the first principle of derivative. It is called the first principle of derivative. Now to understand the first principle of derivative, it is very important that you know one topic called as limits. So before you begin with the first principle of derivative, you will have to understand what limits is. Without limits, the first concept cannot be understood. So make sure that you know limits and continuity first of all, and then you can go to derivatives. The second one that you'll be learning in derivatives is the standard functions, or you can say the basic functions. Derivative of standard functions. Okay, so that's the second point that you are going to learn. The third one would be composite function. Students, in our today's session, we are specifically going to learn these two parts, how to get the derivatives of the standard functions, and then we will be looking into the composite functions as well, and we will obviously see some questions. So this composite functions. Then you have inverse trigonometric functions, then you have logarithmic functions. You can also take exponential functions, the derivatives of logarithmic and exponential functions. Then you have higher order derivatives. So basically these are a few of the types of derivatives that we will be looking into this particular chapter. So as I said, we are today going to understand what standard function is, getting the derivatives of standard function, and later on we will also look into the concept of composite function. We will make a separate video for understanding the first principle of derivative because it needs some concepts of limits also. So keep watching for other lectures as well. Or there I'll be taking first principle of derivative. So in our today's session, we will first of all understand how to get derivatives of standard function, and then we will understand what composite functions are. So let's begin. So the standard functions, when I say, basically derivative is nothing but formula based. You have to understand the formulas of derivative. Once you know the formulas very well, the next part becomes quite easy. So formula understanding is very important. Take a look at this. When I say standard functions, observe what standard functions you'll be encountering. So if I write standard functions, the very first standard function that you want to remember is x raised to n. I want to get x raised to n. So the derivative d by dx of x raised to n is what I want to find. So as I said, derivative is nothing but what? It is a rate of change of a function with respect to other function. For instance, we have already discussed velocity. So how do I express this rate? That is very important. So velocity is nothing but what? Rate of change of displacement, isn't it? Rate of change of displacement. Now if I recognize displacement with say x, I'm going to represent displacement with x, and rate of change of displacement with respect to, so WRT stands for with respect to time, and I'm going to denote it with say small t. So I can write velocity is nothing but rate of change of, so d by dt of x. So for simplicity purpose, we will write it as dx upon dt. Now remember, when I say dx upon dt, it does not mean that dx and dt are two separate quantities. This is a very important part of derivatives that you want to remember. So if you want to represent rate, the rate of change of a function with respect to the other function, this rate of change of a function is denoted by d by dt. So who is changing? The displacement is changing. It is changing with respect to what? With respect to the time. So this d by dt is called as rate measure. It is called as rate measure. So likewise, if I write here the change in x raised to n with respect to x, this is what the meaning of derivative is. So I can write here dx by dt, where dx and dt, they are not two separate quantities. Remember that dx and dt are not two separate quantities. You cannot call this is dx and this is dt separately. Not possible. It is d by dt of x. So whenever you are going to learn derivatives, you should always remember that d by dt is called as an operator. It is called as an operator of derivative. It is called as an operator of derivative. So students, this is how we basically define a derivative. It is rate of change of a function with respect to some other function. The other function is usually time. Most of the times it is time. And some function you take and you find its rate of change with respect to time. So that is what derivative is. So here I am going to write d by dx of x raised to n. It simply means x raised to n is my function, say f of x, and I am trying to find its derivative with respect to the variable x. here rate of change of the displacement with respect to time. So x and t are the variables. X is called as the dependent variable. It is called the dependent variable. It depends on t, isn't it? T is called the independent variable. It is called the independent variable. So I can call here x raised to n as my function. I can also write it y is equal to x raised to n. So I can write dy by dx, isn't it? It is actually d by dx of y, and y is x raised to n. So that's d by dx of x raised to n. Now I'm going to write the derivative here, the formula here directly. But remember that all these things can be proved using limits, the first principle of derivative. We are not taking that concept in this lecture. We have a separate lecture just to understand first principle of derivative. So in here, remember that derivative is written as d by dx. X is the independent variable. We are differentiating x raised to n. The formula for this goes as n x raised to n minus 1. Students, make sure that you are noting down all these things as and when I am explaining, because I'll be wiping out these all things from the board. So make sure you have taken your notebook, your pen along with you, and you are writing down the things also. So the first function that I had was x raised to n, and its derivative came n x raised to n minus 1. So that's my first standard function. So if I now take the second function, if I ask you the derivative of x, I'm going to ask you the derivative of x. So did you observe, for derivative of x, I can use the same formula, derivative of x raised to n. Here the value of n is 1. So I can write the derivative of x. It is going to be, n is taken as 1, isn't it? X raised to n. So n is taken as 1 into x raised to, n is 1, so 1 minus 1. So I get 1 into 1 minus 1 becomes 0. So that's x raised to 0. And don't we all know that a raised to 0 is 1. So that's 1 into x raised to 0, which simply comes out to be 1. So students, from here we have understood that derivative of x raised to n is n x raised to n minus 1, and derivative of x is 1. Likewise, if I move ahead to the next function, so that was x raised to n. If I move ahead to the next function, let us say root of x. So now you know the basic concept of derivative. So I'm going to wipe out all the things from here. So we have seen the first formula, x raised to n. Then we have seen the derivative of x. Suppose if I go ahead and ask you the derivative of x square. So again, it is like x raised to n, and the derivative was n x raised to n minus 1. So here n is 2, so I write 2. Isn't it? X raised to 2 minus 1. So that's 2 minus 1 is 1. So the answer came 2x. It's that simple, isn't it? So derivative of x square came 2x. Likewise, you can get derivative of any particular power. That means, suppose if I'm going to ask you the derivative of root x. So the third standard form, derivative of root x. So if I want to get the derivative of root x, can I write it d by dx of root is something x raised to half, if you know, isn't it? Root of x can be written as x raised to half. So it is like again x raised to n, and the answer is going to be n, which is half, into x raised to n minus 1. So I get 1 by 2, x raised to minus 1 by 2. We all know that a raised to minus m is 1 upon a raised to m. So I'll be getting 1 upon 2, 1 upon x raised to 1 by 2, minus half has gone down, and x raised to half is root, so 1 upon 2 root x. That means the derivative of root x came 1 upon 2 root x. Very important, the third formula. Let's move ahead, one more formula I'll take. So if I now ask you derivative of say 1 upon x, I'm going to ask you derivative of 1 upon x. So can I write it d by dx of x raised to minus 1, isn't it? Don't you all remember that a raised to minus m can be written as 1 upon a raised to m. So the reverse is also true. So 1 upon a raised to m can be written as a raised to minus m. Here x has power 1. So when x goes in the numerator, becomes x raised to minus 1. So I'm going to get my derivative as, so again, look at this, x raised to n, isn't it? The formula was x raised to n. The answer comes n x raised to n minus 1. What is n here? It is minus 1. Then x raised to n minus 1. So n is minus 1 minus 1. That gives me minus 1, x raised to minus 2. Same property of law of indices I'm going to use here. So I get minus 1, 1 upon x square. So the answer came minus 1 upon x square. So students, that's your fourth formula that you want to remember. Let's quickly revise the formulas. So derivative of x raised to n, it is n x raised to n minus 1. Derivative of x, it was 1. Then derivative of root x, it is 1 upon 2 root x. Then derivative of 1 upon x came minus 1 upon x square. Let's move ahead. One formula you should also remember again. The fifth formula I'm going to write here. Derivative of a constant. Derivative of a constant. So the derivative of a constant, d by dx of a constant, so there is no x here, isn't it? There is no x here. So can I say, I can write it derivative of constant. It can be anything. It can be 5, it can be 27, it can be minus of 34. You can take any constant that you want. So let's write it as k, constant. Can I write k into x raised to 0? Isn't it? Constant usually goes outside the derivative. Whenever there is a function of x available, the constant will always go outside the derivative. So I can take out the k, d by dx of x raised to 0. Again it looks like x raised to n, isn't it? The formula is n x raised to n minus 1. So I write k, n comes down, which is 0, x raised to 0 minus 1. But anything when multiplied with 0, the answer comes what? 0. That means the derivative of a constant is going to be what? 0. So make sure that you have understood these first 5 formulas. So derivative of x raised to n was n x raised to n minus 1. The derivative of x, it was 1. The derivative of root x, it is 1 upon 2 root x. Derivative of 1 upon x came minus 1 upon x square. And derivative of constant came 0. Got that part very properly? The next thing that we are going to learn is the derivative of trigonometric functions. Now in the trigonometric functions, the first function that we want to understand is sin x. So I'm going to get derivative of sin x. So the derivative of sin x, again students, I'm telling you this, all these derivatives, all these formulas that I'm telling you can be proved using something called as the first principle of derivative. In this session we are not learning it, we have a separate session just to understand the first principle of derivative. At that time we will be discussing the definition of derivative also in detail. So at this moment just relax and only understand how the formulas are written. Just try to memorize these formulas. So derivative of sin x, it comes out to be cos x. That was your 6th formula, isn't it? Up to constant we have written 5 formulas. So make sure that you are also noting these formulas down. Take a pen, take a paper and keep on writing these formulas. Do it for your own, what you can say, sake of good, isn't it? Once you keep on writing the formulas, it is just going to help you out to understand some critical questions that we are going to take later in this video. So derivative of sin x, it is cos x. Similarly, if I go ahead, derivative of cos x. So that's a trick that you want to remember. Whenever a c comes, the derivative will have a negative sign. Remember this trick. Whenever a c comes, the derivative, the answer will have a negative sign. So the answer here is minus of sin x. So that's the derivative of cos x. Let's move ahead. Derivative of tan x. So the derivative of tan x is sec square x. Then let's take the next one, derivative of cot x. So the derivative of cot x is, see again c has come, isn't it? When cos x was written, it has a c, the answer came negative. When cot x is written, again it has a c, again it will have a negative sign, and the derivative of cot x comes out to be minus of cosec square x. Look at the standard functions, sine, cos, tan, cot. Can you think about the next 2 standard functions? Obviously it is sec x and cosec x. So the next one, the 10th one, it is going to be derivative of sec x. So derivative of sec x comes out to be sec x into tan x, and the 11th one, derivative of cosec x. So again a c has come, isn't it? Again a c has come. So I'll write the answer as minus of cosec x into cot x. Got that part very clearly? Now after these trigonometric functions, let us take the derivatives of exponential functions and logarithmic functions. So students, derivative of e raised to x, it is e raised to x only. Again, I am telling all of these formulas we are going to derive by looking at the first principle of derivative in our other session. So let us not worry how these formulas are coming. At this moment, you just keep on noting down all the formulas in your notebook. So derivative of e raised to x is e raised to x. Then the 13th one, derivative of a raised to x is a raised to x into log a. So the derivative of a raised to x is a raised to x into log a. So if you try and take e raised to x, so derivative of e raised to x can be written as e raised to x into log of e. But we all know that log of e, the answer is 1. Now, whenever you are dealing with derivatives, that means the calculus part, either it be derivatives or it be integration or it be differential equation or any other thing which is related to calculus part, always and always remember the logs that are involved here, they are by default with the base e. The base is always and always taken as e. If it is not mentioned anything, by default the base of the log is going to be e. If I mention it something else, say log of a to the base 10, at that time derivative is not possible. The derivative is possible only when the log has base e. That means if I go ahead to write one more formula, so I'm going to remove one of the formulas from here. I hope you have noted down these formulas. Make sure that you are noting down the formulas. So the next formula I can write here, derivative of log x. So d by dx of log x. So as I've just now told you, whenever a log is written in calculus, when I say calculus, it means limits, derivatives, continuity, integration, differential equation, any other thing that is related to the study of a curve. At that time, log is always by default what base? The base is always taken as e unless and until it has been mentioned something else. So log of x, the derivative of log of x is 1 upon x. So students, so far we have learned 14 different formulas of derivative. Let's quickly revise them. So there was nothing but what? X raised to n. Then there was, the formula was n, x raised to n minus 1. Then derivative of x, it was 1. The derivative of root x, it was 1 upon 2 root x. The derivative of 1 upon x, it was minus 1 upon x square. The derivative of a constant, it was 0. Derivative of sine, it was cos x. Derivative of cos, c has come, so the answer will contain a negative sign. So derivative of cos x, it was minus sine x. Derivative of tan x, it is sec square x. Cot x, it is minus cos x square x, again c has come, so minus cos x square x. Derivative of sec x, it was sec x tan x. Derivative of cosec x, it is minus of cosec x cot x, again a c has come. Derivative of e raised to x is e raised to x. Derivative of e raised to x is a raised to x log a. Derivative of log x is 1 upon x. Now, after this set of formulas, there are few more standard functions which are left, which will be called as inverse trigonometric functions. You know there is sine inverse of x, cos inverse of x, tan inverse of x, sec inverse, cosec inverse, cot inverse. So there are 6 trigonometric inverse functions that we have to learn, and every trigonometric inverse has derivative. There is formula available, but we are not going to learn it into this session. Again, we will be conducting a different session to understand the derivatives of inverse trigonometric functions. So at this moment, to just begin with the topic, these many formulas are more than enough to begin with the chapter. Now, this was our first session. Here we have learned all the basic formulas of derivative. Students, in our next session, we are going to learn a very important part of derivatives, and that is called as a derivative of composite functions. Composite functions, if you know how to identify the composite functions, what would be the derivative of the composite functions, believe me, you are definitely going to enjoy this topic learning, because once you know these concepts of composite functions and their derivatives, many of the things will become very easy into this chapter. So students, I'm going to leave you here at this moment. You make sure that you revise all the formulas before you come to the next session. Thank you so much for watching. Have a great day ahead.